28 million light-years from Earth floats a cosmic masterpiece, the Sombrero Galaxy. Its beautiful, serene appearance is a brilliant deception. Concealed within its swirling dust and starlight are 50 of the universe's most confounding objects, each one a mystery that challenges our fundamental understanding of space. By the end of this journey, you will know the 50 strangest secrets this galaxy holds, from the twin monsters warring at its heart to ghostly stars flung into the eternal dark. We will uncover why its core glows with an impossible light and what silent, invisible forces twist its very shape. How well do we truly know the cosmos when a single galaxy can hold so many enigmas? At the very heart of the Sombrero Galaxy, where logic suggests a single, unifying force should reign, astronomers have found a profound contradiction. The core appears to be split, hinting at a duality so strange it defies our basic models of how galaxies form. High-resolution images from the Hubble Space Telescope and data from the Chandra X-ray Observatory have not revealed one, but two distinct brightness peaks at the galactic center. This has led to a compelling and terrifying hypothesis. Two supermassive black holes, each weighing millions of times more than our Sun, could be locked in a slow, gravitational waltz around one another. This is the twin nucleus mystery, the first of our 50 strange objects. The evidence for this cosmic dance is written in the galaxy's own history. The Sombrero possesses an immense, smooth halo of stars, a classic telltale sign of a past galactic merger. Billions of years ago, it likely devoured a smaller neighbor, and the central black holes of those two galaxies are now all that remains, spiraling toward an eventual collision. Yet, not all scientists are convinced. Some propose the second bright spot could be an incredibly dense, spinning cluster of ancient stars, packed so tightly they mimic the signature of a black hole. The debate hinges on strange X-ray flares and peculiar radio wave emissions that seem to point toward the violent environment around a black hole, but the final answer remains elusive. This fundamental uncertainty at the galaxy's very center sets the tone for everything we are about to discover. If we cannot be sure what lies in its heart, how can we hope to understand the other 49 enigmas waiting in the dark? This invisible giant at the galaxy's core is a confirmed supermassive black hole of almost unimaginable proportions. While the twin nucleus mystery remains unresolved, the primary force anchoring the Sombrero's heart is a single gravitational monster with a mass estimated at around 1 billion times that of our own Sun. To put that into perspective, if our Sun were the size of a marble, this black hole would be as massive as a mountain. This sheer size is the second of our 50 strange objects, and it is deeply puzzling. For a galaxy of the Sombrero's type and overall mass, this black hole is an extreme outlier, far more massive than our existing models of galaxy evolution predict. It is a behemoth that should not, by our current understanding, exist in this particular cosmic neighborhood. So how do we even begin to weigh such an invisible object? Astronomers cannot see the black hole itself, but they can meticulously track the frantic dance of stars and hot gas whipping around its cosmic drain. By measuring the incredible speeds of these stars as they orbit the central void, scientists can calculate the immense gravitational pull required to hold them in such a tight, fast-moving dance. The math is inescapable, pointing to a gravitational presence of 1 billion solar masses. This invisible giant's influence is not subtle. It actively shapes the entire central region of the galaxy, dictating the orbits of millions of stars and compressing vast clouds of gas and dust. Yet here lies another layer to the mystery. With such a voracious appetite for matter, why is this black hole so quiet? We would expect a monster of this size to be a brilliant quasar, blazing with energy as it consumes everything nearby. Instead, it sits in a strangely starved and dormant state, emitting only a faint whisper of the radiation it is capable of producing. This quietness is as confusing as its immense size, suggesting that for reasons we do not yet understand, the flow of cosmic fuel onto this invisible giant has been abruptly shut off. That same gravitational giant may be responsible for twisting the galaxy's most beautiful feature into a cosmic puzzle. From our distant viewpoint, the sombrero's defining dust lane appears as a pristine, razor-thin brim. But closer inspection reveals this is an illusion. The third strange object is the sombrero's warped dust ring itself. This iconic band of cosmic silt and gas is not the perfect circle it seems. It possesses a subtle but definite warp, a slight twist and bend that defies the simple elegance we see from afar. How does a structure so vast and seemingly stable develop such a kink? The leading theory points to a gravitational encounter, a close pass by a smaller satellite galaxy whose unseen tug pulled and distorted the ring over millions of years. This would be a ghostly hand reaching out of the dark to leave a permanent fingerprint on the galaxy's face. The warping is not the only strangeness. The dust is not a smooth, uniform sheet. It is a chaotic landscape of intricate filaments, dense knots, and sudden gaps. These features are the birth cries and death throes of stars. Within those dark knots, immense pressure is collapsing gas and dust to forge new suns, their violent stellar winds then carving out the surrounding gaps and shaping the filaments. The entire ring is a dynamic, living entity, constantly being reshaped by the very processes of creation happening within it. This means the sombrero's serene portrait is a snapshot of ongoing cosmic violence. Its most stable-looking feature is both warped by past collisions and churned by newborn stars, a beautiful mask hiding a deeply turbulent reality. Far beyond the galaxy's warped brim, adrift in the immense cosmic dark, floats a lonely star city known as MGC-1. This is the fourth strange object, a globular cluster so distant from the sombrero's bright core that its isolation defies belief. While most globular clusters swarm close to their host galaxy, MGC-1 orbits at a staggering remove, a solitary island of stars in a vast, empty ocean. Its very existence prompts a fundamental question. How did it get so far out here, and what does its loneliness tell us about the sombrero's hidden past? The answers are written in the ancient light of its stars. MGC-1 is not just distant, it is also profoundly different. Its stellar population and metallicity, which is the amount of heavy elements fused within its stars, are distinct from all the other clusters in the sombrero's system. This is a critical clue. Think of it like finding a single person in a large crowd who speaks a completely different language and wears unfamiliar clothing. This person clearly comes from somewhere else. In the same way, MGC-1's unique chemical signature suggests it did not form with the Sombrero Galaxy. It is an immigrant, a cosmic orphan that arrived from another place entirely. The most compelling theory is that this isolated cluster is the lone surviving relic of a dwarf galaxy that was torn apart and consumed by the Sombrero billions of years ago. In this violent act of galactic cannibalism, the smaller galaxy was shredded, its stars scattered and absorbed into the Sombrero's great halo. But at its heart, its central star cluster, MGC-1, proved too gravitationally tough to break apart. It was flung out to the periphery, a ghostly leftover from a long-dead galaxy, now forever bound to the entity that destroyed its home. Studying this faint, distant object is an immense challenge, pushing our most powerful telescopes to their limits. Its light is incredibly faint, and its great distance makes detailed analysis a painstaking task. Yet its persistence tells a dramatic story. MGC-1 is a silent witness, a celestial fossil that provides undeniable evidence of the Sombrero's violent and acquisitive history. It proves that the galaxy's serene appearance is a mask hiding a past filled with collisions and consumption, where smaller galaxies were devoured and only the hardiest remnants like this strange, lonely cluster were left behind. Deep within the galaxy's spiral arm, a single point of light defies all known laws of physics. This is the fifth strange object, an ultra-luminous X-ray source known simply as a ULX. It is not a star, not a quasar, but something entirely different, pouring out more X-ray energy than a million suns. The sheer power is baffling because it seems to originate from a single, compact object, challenging everything we know about cosmic power plants. A typical stellar mass black hole formed from a collapsed star simply cannot reach this level of brilliance. So what exactly are we looking at? This ULX could be the long-sought missing link in black hole evolution, an intermediate mass black hole. These are the cosmic middleweights, with masses ranging from a few hundred to a few 100,000 times that of our Sun. They are notoriously elusive, and finding one would solve a major mystery in astrophysics, bridging the gap between small stellar black holes and the supermassive giants that anchor galaxies. Yet, not all astronomers are convinced. Another compelling theory suggests this could be a more ordinary stellar mass black hole, but one that is feeding on matter at an absolutely frantic, unsustainable rate. This creates a superheated accretion disk that glows with unimaginable intensity. Alternatively, the light might not be shining in all directions equally. It could be beamed, focused into a narrow jet pointed directly at us, like a cosmic lighthouse making its light appear deceptively bright from our particular viewpoint. Observations from the Chandra X-ray Observatory have only deepened the puzzle. They show the source flickering and flaring in unpredictable ways, its energy signature shifting over time. This variability suggests a chaotic, violent environment where matter is being torn apart and consumed in fits and starts. The data refuses to fit neatly into any single model, leaving astronomers with more questions than answers. This single point of intense light, a pinprick in the vastness of the Sombrero, stands as a stark reminder that some of the universe's most energetic processes remain completely unknown to us. While the ULX blazes with impossible light, another object is fleeing the galaxy at a breathtaking speed. The sixth strange object is the hypervelocity globular cluster HVGC1, a massive family of stars that appears to be escaping the Sombrero Galaxy entirely. This is not a slow, wandering orbit, it is a high-speed dash for the exit, a trajectory that suggests it was violently flung out from the galaxy's core. The forces required to eject something as massive and gravitationally bound as a globular cluster are almost unimaginable, pointing to a dramatic event in the Sombrero's past. The most likely culprit is the gravitational slingshot effect from the proposed binary black holes at the galaxy's heart. Picture two immense dancers spinning around each other, their gravitational fields creating a chaotic zone of influence. If a third object, like a star cluster, ventures too close, it can be caught in their dance and hurled outward at an incredible velocity, like a stone from a sling. HVGC1 could be that stone, a celestial projectile launched by the twin monsters we suspect reside in the center. Yet its story of exile is only half the mystery. This cluster is also a chemical anomaly. Its stars are richer in heavy elements, what astronomers call metals, compared to the other ancient metal-poor clusters that typically inhabit the galactic halo. This distinct chemical fingerprint is a powerful clue to its origin. It suggests HVGC1 did not form in the quiet, primordial outskirts of the galaxy. Instead, it was likely born in a much denser, more metal-rich region, closer to the bustling galactic center where generations of stars had already lived and died, seeding the cosmos with heavier elements. So, was it born in the core and then violently evicted, or was it a captured cluster that made a fatal pass too close to the central black holes? Its high velocity and unique composition make both scenarios possible, painting a picture of a dynamic and often brutal galactic environment. The existence of this runaway cluster forces us to reconsider the stability of star clusters. We often think of them as permanent, stable fixtures, but HVGC1 proves they can be sent careening across the galaxy or even cast out into the intergalactic void. It is a testament to the immense, unseen forces that constantly shuffle the cosmic deck, reminding us that even the largest structures are subject to the universe's chaotic and violent whims. These runaway stars and clusters are not the only things shaped by invisible forces. The Sombrero Galaxy itself is embedded within a vast, unseen scaffold, a halo of dark matter that should be its perfect, symmetrical cocoon. But this scaffold is warped. The seventh strange object is the galaxy's profoundly asymmetric dark matter halo. Standard models of cosmology predict that this invisible substance, which makes up most of the galaxy's mass, should form a roughly spherical cloud around the visible disk. Yet every measurement we have of the Sombrero tells a different story. The rotation curve, which charts how fast stars orbit at different distances from the center, reveals a gravitational pull that is uneven. The motions of its globular clusters, those distant star cities, trace paths that cannot be explained by the gravity of the stars and gas we can see alone. Their orbits suggest the dark matter is not a smooth sphere, but is instead lopsided or flattened, a cosmic pillow that has been squashed on one side. This is like discovering that the air in a room is not evenly distributed, but is mysteriously thicker in one corner, exerting a strange, constant pressure. What could have caused such a fundamental distortion in the galaxy's hidden skeleton? The most compelling explanation points to a violent past, a major merger with another galaxy. The same event that may have delivered the lonely cluster MGC1 could have violently disturbed the dark matter distribution. The gravitational turmoil of two galaxies colliding and merging would have sloshed and stirred the dark matter, leaving it permanently out of balance, like water in a bowl that was violently shaken and never quite settled. But there is a more radical possibility. This asymmetry might not be a relic of a past collision, but a clue to the intrinsic nature of dark matter itself. Perhaps dark matter particles can interact with each other through forces beyond gravity, creating friction or pressure that allows the halo to flatten and distort over time. The Sombrero Galaxy, with its clear and unusual signals, has become a critical test case in this grand cosmic puzzle. Its lopsided halo is a direct challenge to our simplest models, forcing us to ask if we truly understand the properties of the universe's most dominant, yet most elusive component. This invisible asymmetry is perhaps the strangest object of all, for it is a shape defined by absence, a ghostly hand whose grip we can only feel but never see. This potential for a lopsided dark matter halo is mirrored by a ghostly structure in the starlight itself. Wrapped around the galaxy's poles is a faint, ethereal ring of debris, orbiting at a perfect right angle to the bright main disk. This is the eighth strange object, the evidence for a polar ring around the Sombrero Galaxy. It is not the prominent, well-defined ring seen in some other galaxies, but rather a collection of faint streams and arcs of stars, a delicate fossil of a catastrophic encounter. Spotting this structure is like trying to see a faint whisper of smoke next to a brilliant spotlight. The overwhelming glare from the galaxy's massive central bulge easily washes out these tenuous threads of light. Only through deep, painstaking observations and sophisticated computer processing that removes the dominant glow of the bulge can we even begin to trace its subtle outline. The existence of this ring points to a specific and violent chapter in the galaxy's life. The leading theory is that a smaller, gas-rich dwarf galaxy ventured too close to the Sombrero billions of years ago. The immense tidal forces of the larger galaxy would have shredded this intruder, tearing it apart. But instead of being completely absorbed, the debris from the cannibalized galaxy was flung into a stable orbit over the poles, perpendicular to the main disk. This is a cosmic accident frozen in time, a ring of stellar wreckage circling the giant that destroyed its source. If confirmed, this polar ring would be a treasure trove of information. Because it orbits on a different plane, it allows astronomers to map the Sombrero's gravitational field in 3 dimensions, offering an independent way to measure the distribution of both visible and dark matter. The very presence of such a ring suggests the Sombrero's assembly was far more dramatic than its serene appearance implies, built through a series of violent acquisitions that left their marks in the most unexpected places. This ghostly ring of debris is a celestial scar, a permanent record of a past collision that continues to orbit the galaxy, a silent witness to the chaotic forces that shaped this cosmic masterpiece. Nestled within the galaxy's dark, elegant brim is a splash of color that should not be there. This is the 9th strange object, an enigmatic blue blob of intense star formation burning like a brilliant sapphire against the cosmic silt. It is a stellar nursery of staggering violence and beauty, a region crammed with a population of young, massive stars. These are the universe's rock stars, burning ferociously hot and bright, living fast and dying young. Their brilliant blue-white light and intense ultraviolet radiation flood the surrounding space, illuminating the very dust clouds that gave them birth. But their existence in this precise location is a profound puzzle. The Sombrero's disk is not a hotbed of widespread starburst activity. It is generally a quiet and mature galactic neighborhood. So why is this one spot erupting with such youthful, violent energy? What triggered this sudden, isolated firestorm of creation? Astronomers are investigating several compelling possibilities. Perhaps a collision occurred, 2 massive clouds of gas smashing together in the dark, their impact compressing the material and igniting a chain reaction of star birth. Or the trigger could have been a shock wave from a nearby supernova explosion, the titanic death of a previous star sending a powerful ripple through the surrounding gas, squeezing it into new suns. There is an even more exotic theory that an invisible clump of dark matter, a substructure within the galaxy's halo, passed through this region. Its concentrated gravity could have acted like a cosmic hand, silently compressing the gas and triggering the starburst from the shadows. This brilliant blue anomaly challenges our understanding of what sparks star formation in a seemingly placid galaxy. It proves that serenity is only an illusion, that even in the most quiet corners of the cosmos, pockets of violent, brilliant creation can flare up without warning, leaving us to wonder what other hidden forces are at work. These rogue clouds of hydrogen gas are racing through the Sombrero's outskirts at impossible speeds. This is the 10th strange object, a population of high-velocity gas clouds that defy the galaxy's orderly rotation. They are not moving with the serene flow of the main disk, but are instead caught in a frantic, chaotic motion, some plummeting inward while others appear to be flung outward into the void. We cannot see this neutral hydrogen with optical telescopes. Its signature is revealed only through the silent language of radio waves. Giant radio observatories like the Very Large Array have mapped these clouds by tuning into the faint whisper of the 21-centimeter line, a specific frequency that hydrogen atoms naturally emit. The data paints a picture of a galaxy surrounded by a turbulent, fast-moving shroud of gas. What force could possibly be hurling these immense clouds around with such violence? The prime suspects are the galaxy's own powerful engines. One possibility is that fierce stellar winds from the brilliant blue starburst regions we encountered earlier are acting like cosmic pressure washers, blowing gigantic bubbles of gas out of the disk at tremendous speeds. An even more powerful culprit could be the quiet supermassive black hole at the galaxy's heart. Even in its dormant state, it may occasionally burp or flicker, releasing vast amounts of energy that push against the surrounding medium and accelerate these clouds to their extraordinary velocities. Yet there is another, equally compelling origin story for these rogue clouds. They could be the ancient, leftover building blocks of the galaxy itself, pristine packets of primordial gas that never fully collapsed to form stars. These are cosmic fossils falling into the Sombrero's grasp for the very first time. billions of years after the galaxy's main structure was assembled. Alternatively, they might be the shredded remains of tiny satellite galaxies, their stars long since absorbed, but their gas being stripped away by the Sombrero's gravitational tides and dark matter halo, leaving behind these ghostly, fast-moving streamers. This makes these clouds vital to the galactic ecosystem. The infalling clouds are a delivery service of fresh fuel, providing the raw hydrogen needed for future generations of stars, slowly replenishing the galaxy's dwindling reserves. The outgoing clouds, however, tell a story of loss, a process where the galaxy ejects its own potential for future life out into intergalactic space. This constant cycle of infall and ejection reveals a galaxy that is still breathing, still dynamically interacting with its environment in ways we are only beginning to understand. This overmassive bulge is the Sombrero's most dominant feature, a brilliant, swollen core of ancient stars that contains a staggering fraction of the galaxy's entire stellar mass. It is the 11th strange object, a central city of stars so vast and dense it overshadows the elegant disk that surrounds it. In most spiral galaxies, the bulge and the disk exist in a more balanced partnership. But here, the bulge is the undeniable heavyweight, its sheer scale and luminosity defying expectations. Its stars are overwhelmingly old, having burned for billions of years, and their collective glow creates a surface brightness so intense it can wash out fainter details. This presents a direct challenge to models of galaxy formation that predict a tighter correlation between the size of the bulge and the size of the disk. Why is this central stellar metropolis so disproportionately large? The answer may lie in a violent beginning. One compelling theory suggests the Sombrero Galaxy is the product of an ancient major merger, a colossal impact between two large gas-rich galaxies in the early universe. Such a cataclysm would have funneled a tremendous amount of material directly into the galactic center in a relatively short time, building up this overmassive bulge in a rapid, violent burst of star formation. The alternative is a more monolithic but equally dramatic process where the bulge formed quickly and early from a vast, collapsing cloud of primordial gas before the more orderly disk had time to fully develop around it. The mystery deepens when we study how the stars within this bulge actually move. Their orbits are not simple or uniform. While many follow the expected, random paths of a classical bulge, there is evidence of a more ordered rotation, a signature of what astronomers call a pseudo-bulge. This suggests a more complex history where the central structure was not only built by a single violent event, but also shaped over time by the steady influence of the galaxy's spiral arms and bar-like structures, which can funnel gas inward to form new stars in the core. So, is the Sombrero's core a classical bulge born from a cosmic collision, or a hybrid pseudo-bulge shaped by internal processes, or both? This fundamental question about its structure is key to unlocking the galaxy's entire life story. The overmassive bulge is not just a strange feature, it is the architectural keystone of the Sombrero, and its unusual proportions hold the secrets to how this entire cosmic masterpiece was assembled. The brilliant bulge and chaotic gas clouds of the Sombrero exist within a cosmic void far emptier than it should be. This is the 12th strange object, a profound absence known as the missing satellite galaxy problem. According to our most successful model of the universe, the Lambda CDM model, a galaxy as massive as the Sombrero should be surrounded by a bustling swarm of dwarf satellite galaxies, perhaps hundreds of them, each held in its gravitational grip by a small clump of dark matter. Yet our telescopes find only a handful of faint, uncertain candidates. It is like expecting to find a vibrant city surrounded by suburbs and towns, only to discover a near-empty landscape with just a few scattered huts. This is not just a local oddity, it is a cosmological crisis that challenges the very foundations of how we think the universe is structured. Where did all the missing dwarfs go? One possibility is that they are simply too dim for us to see. These failed galaxies might be so faint, composed of mostly dark matter with very few stars, that they blend into the blackness of intergalactic space, hiding just beyond the limits of our current observational power. The next generation of telescopes, like the Nancy Grace Roman Space Telescope, is designed specifically to hunt for these ghostly shadows. Another, more violent explanation is that the Sombrero has already consumed its entire entourage. Its history of mergers, evidenced by the Lonely Cluster MGC1 and the potential polar ring, suggests a past of galactic cannibalism. Over billions of years, it may have torn apart and absorbed almost all of its satellite galaxies, leaving behind only the few hardy survivors we see today. The Sombrero's relative isolation in space could have made this feast particularly efficient, with no other large galaxies nearby to steal its satellites away. But the most radical possibility is that our understanding of dark matter itself is flawed. Perhaps dark matter is warmer or interacts differently than we think, which would prevent the formation of as many small clumps, naturally leading to a scarcity of dwarf galaxies. The profound silence around the Sombrero Galaxy is a powerful message. Sometimes the most important discoveries are not about what we find, but about what we cannot see. This strange, empty frontier forces us to question whether we are missing most of the cosmic picture, or if the universe's blueprint is far more complex than we ever imagined. Floating silently through the cosmos, the Sombrero Galaxy emits a faint, high-energy whisper. This is the 13th strange object, an unusual flux of gamma rays that paints the galaxy in light 1 trillion times more energetic than what our eyes can see. Detected by instruments like the Fermi Gamma Ray Space Telescope, this persistent glow is puzzling. For a galaxy of the Sombrero's relatively quiet type and advanced age, such a strong gamma ray signal is somewhat unexpected. It is not the brilliant beacon of an active quasar, but a faint, diffuse shimmer that hints at hidden engines churning within its spiral arms. This radiation is the signature of the universe's most violent particle accelerators. The conventional explanation points to cosmic rays, which are atomic nuclei traveling at nearly the speed of light, constantly zipping through the galaxy. When these particles collide with the nuclei of atoms in the thin interstellar gas or get deflected by magnetic fields, they can produce gamma rays. It is a natural form of cosmic background radiation. Yet, the measured flux from the Sombrero is a bit higher than some models predict for this process alone. The numbers do not quite add up, suggesting another, more exotic source is contributing to this high-energy glow. One compelling possibility is a vast, unseen population of pulsars. These are the rapidly spinning, ultra-dense cores of dead stars, acting like celestial lighthouses that beam out radiation. Thousands of these faint, unresolved objects could be scattered throughout the galaxy, their collective emissions blending into the diffuse gamma-ray signal we detect from millions of light-years away. A more speculative theory involves the galaxy's immense halo of dark matter. If dark matter particles are their own antimatter counterparts, they could annihilate upon contact, transforming their mass directly into a burst of gamma-ray energy. The Sombrero's dense dark matter halo would be a perfect place to look for such a signal. We also cannot rule out the supermassive black hole at the center. Although it is quiet now, it may be in a state of low-level activity, occasionally accelerating particles to high energies that then escape and interact with the galaxy, contributing to the gamma-ray flux. Pinpointing the exact source is incredibly difficult from such a vast distance. The gamma rays we collect are just a handful of photons after their long journey, making detailed analysis a monumental task. Future observatories with more sensitive gamma-ray detectors will be crucial. They might finally resolve this faint glow into individual points of light, identifying the pulsars, or they might confirm that the signal is truly smooth and diffuse, strengthening the case for a dark matter origin. This enigmatic gamma-ray whisper is a reminder that the cosmos speaks in many energies, and the Sombrero is telling us a story we are only just beginning to hear. Even the majestic spiral arms of the Sombrero Galaxy hide a strange and silent secret at their edges. This 14th strange object is the galaxy's red and dead outer disk. Unlike most spiral galaxies, where the outer regions are often vibrant nurseries for new stars, the Sombrero's distant suburbs are dominated by a population of ancient red stars. These old suns have burned for billions of years, their cool, red light a testament to a long and quiet existence with very little recent star formation. It is a fossilized frontier, a stellar population that has essentially retired from the dynamic business of cosmic creation. How does a spiral galaxy, a structure famed for its ongoing star birth, develop such a quiescent outer rim? The most straightforward theory is that the Sombrero simply ran out of fuel in these distant reaches. Perhaps its original supply of primordial hydrogen gas in the outer disk was exhausted long ago in one intense early burst of star formation. With no fresh gas to collapse into new suns, the star-making process ground to a permanent halt, leaving behind only the aging, red stars as a memory of that initial frenzy. A more dramatic possibility is that a specific event quenched the outer disk. A past interaction with another galaxy could have violently stripped away the precious gas reserves, or the galaxy's own immense gravitational field might have somehow prevented new gas from falling in to replenish the outer regions. This leaves us with a critical question about the Sombrero's life story. Does this red and dead disk mean the galaxy is in a more advanced stage of evolution than its spiral structure suggests? It could be a cosmic senior citizen, a galaxy that matured rapidly and has now settled into a long, quiet retirement, its outer territories frozen in time. This strange, silent frontier forces us to reconsider the typical life cycle of spiral galaxies. The Sombrero presents a hybrid reality, a galaxy that looks like a vibrant spiral from a distance, but upon closer inspection, reveals an outer disk that has already lived its most exciting life, leaving behind a beautiful crimson fossil for us to ponder. Woven around the galaxy's serene disk is a ghostly river of stars, a silent testament to a long-finished cosmic feast. This is the 15th strange object, a vast tidal stream, the final remains of a dwarf galaxy that was completely torn apart and consumed by the Sombrero. The stream is so faint, so ethereal that it eluded detection for decades, hidden in the overwhelming glare of the galaxy's brilliant core and dust lane. Only through very deep photometry, a technique of collecting light for hours on end with the world's most powerful telescopes, could this delicate structure be revealed. It is a cosmic archaeological dig site, written not in stone, but in the scattered light of billions of orphan stars. The very existence of this stream confirms the Sombrero is a galactic cannibal, its serene appearance a beautiful lie covering a violent history of consumption. The structure and composition of this stellar river tell a detailed story of the destruction. The stream is not a chaotic splash, but a coherent, arching ribbon that wraps around the galaxy. This elegant shape is a direct record of the dwarf galaxy's final orbits, a cosmic fingerprint of the gravitational forces that shredded it. By tracing its path, astronomers can rewind the clock, calculating the precise trajectory and timing of the ancient collision. Even more telling is the stream's metallicity. The stars within it are remarkably metal-poor, meaning they contain very few elements heavier than hydrogen and helium. This is the signature of a truly ancient galaxy, one that formed early in the universe and lived a short, isolated life, never experiencing the multiple generations of star formation needed to enrich its gas with heavier elements. The devoured dwarf was a primitive fossil galaxy from the cosmic dawn. This ghostly stream is more than just a relic, it is a precision tool for mapping the invisible. The shape of the tidal stream is exquisitely sensitive to the gravitational field of the main galaxy. As the stream of stars orbits, its path is dictated entirely by the distribution of mass within the Sombrero, most of which is the unseen dark matter halo. Any lumps, twists, or asymmetries in the stream's form are a direct reflection of lumps and variations in the dark matter distribution itself. It acts like a cosmic probe, tracing the contours of the gravitational well in a way that visible matter alone cannot. A smooth, symmetrical stream would suggest a smooth, spherical dark matter halo. But if the stream shows kinks or substructure, it points toward a more complex, clumpy, or even lopsided halo, echoing the strange asymmetry we discussed earlier. This beautiful, fading river of stars is therefore a key to unlocking the three-dimensional shape of the Sombrero's greatest mystery, its dark matter scaffold, revealing how the ghost of a long-dead galaxy can illuminate the invisible architecture of the present. These cosmic lighthouses, the Cepheid variables, should be our most reliable guides. Across the universe, these pulsating stars serve as standard candles, their predictable rhythms of brightening and dimming allowing us to measure vast distances with confidence. But within the Sombrero Galaxy, the 16th strange object is a population of Cepheids that refuse to follow the rules. Their pulsation periods are slightly off, their light curves subtly distorted, flickering with a rhythm that defies our established models. These are not broken instruments, they are messengers telling us a more complex story than we anticipated. The anomalies could stem from several sources. Perhaps these stars have a different chemical composition, a lower metallicity than the Cepheids we use to calibrate our distance ladder. A star's metal content can affect its internal physics, changing how it pulsates and thus how bright it truly is. Or maybe these are not solitary stars at all, but binary systems where the gravitational tug of a companion star influences the pulsations we observe. Another possibility is that they are Cepheids in a different stage of stellar evolution, their internal structures slightly altered, which in turn changes their pulse. Each of these explanations carries a profound implication for our understanding of the Sombrero's place in the cosmos. If we misjudge the true intrinsic brightness of even a few of these standard candles, our calculation of the galaxy's distance becomes uncertain. Is the Sombrero 28 million light-years away, or is it significantly closer or farther? A small error in distance creates a large error in our estimate of the galaxy's true physical size and its total luminosity. We thought we knew the scale of this cosmic masterpiece, but these anomalous stars have thrown a veil over that certainty. This is not just a problem for one galaxy. It is a potential crack in the foundation of the cosmic distance ladder itself, the tool we use to measure the scale of the entire universe. Resolving this discrepancy is a primary goal for observatories like the James Webb Space Telescope and the upcoming Nancy Grace Roman Space Telescope. Their powerful infrared eyes can peer through the galaxy's dense dust lanes to study these rebellious Cepheids in exquisite detail, untangling the effects of chemistry, companionship, and evolution. Until then, every pulse of light from these strange variables is a reminder that even our most trusted cosmic beacons can flicker with mystery. While we map the silent rivers of stars and the anomalous pulses of light, another invisible force is actively sculpting the galaxy from the inside out. The 17th strange object is the Sombrero's supersonic galactic wind, a vast, high-speed river of ionized gas flowing out from its central regions. We cannot see this wind with our eyes, but its signature is etched into the light of the gas it heats and accelerates. Spectroscopic observations reveal the telltale signs, specific wavelengths of light that are shifted and broadened, indicating that the gas is moving away from the galaxy at speeds far exceeding the velocity of sound within that medium. This is not a gentle breeze, it is a hurricane force outflow powerful enough to reshape the galactic environment. The engine driving this phenomenal wind is a chorus of cosmic violence. It is fueled by the combined fury of countless supernova explosions and the relentless stellar winds blasting from the galaxy's population of massive hot stars, particularly those concentrated in its immense central bulge. Each supernova is a titanic detonation, and each stellar wind is a million-mile-per-hour gale, and together their energy pumps into the surrounding gas, heating it to extreme temperatures and forcing it to expand and flow outward at supersonic speeds. The strangeness lies in the fact that the Sombrero is not currently undergoing a violent, galaxy-wide starburst. We typically associate such powerful outflows with galaxies in the throes of extreme star formation. Yet here, in this seemingly mature and quiet galaxy, the wind persists. This suggests that the cumulative effect of star formation over billions of years, the steady simmer of stellar births and deaths within that overmassive bulge, has generated enough combined energy to power this persistent, large-scale flow. The impact of this wind is profound and far-reaching. It acts as a global thermostat and a regulatory mechanism for the galaxy's own evolution. By violently ejecting heated gas from the central regions and the disk, the wind is effectively removing the primary fuel for future star formation. It is like a fire that consumes its own oxygen supply, limiting its own growth. This process, known as galactic feedback, may be a key reason why the Sombrero's outer disk has become so red and dead. Its star-forming gas slowly being depleted or heated beyond use by this invisible supersonic exhalation. This wind is a testament to a galaxy's ability to shape its own destiny, a self-regulating force born from the collective lives and deaths of its stars, silently governing the future of cosmic creation within its beautiful, swirling form. The Sombrero's immense gravity warps the space around it into a natural telescope. This 18th strange object is the galaxy's own gravitational lens, a phenomenon where its colossal mass bends the light from galaxies far behind it, magnifying and distorting their images into faint, ghostly arcs and multiple mirages. Yet the way this lens bends light is not perfectly smooth or predictable. Some of the lensed images appear stretched and twisted in unexpected ways, creating anomalies that our models of the galaxy's gravity cannot fully explain. The cause lies in the complex distribution of mass throughout the Sombrero. It is not just the combined pull of the brilliant bulge and the disk of stars that creates this lensing effect. The true architect is the invisible dark matter halo, whose uneven and potentially lopsided shape, which we discussed earlier, grips the fabric of spacetime with an unseen hand. When light from a distant object travels through this varied gravitational landscape, it gets warped in a way that directly maps the underlying mass. A smooth, symmetrical halo would produce clean, predictable arcs. The strange distortions we see are therefore a direct reflection of the dark matter's complex and clumpy structure. One of the most compelling examples is a specific, highly distorted background galaxy. Its light has been smeared into a faint, thin arc that curves around the Sombrero's outskirts. By analyzing the exact shape of this arc, astronomers can perform a kind of cosmic tomography, reconstructing a three-dimensional map of where the mass, both seen and unseen, is truly concentrated. In another instance, a single, distant quasar appears as multiple points of light around the galaxy, its image split and copied by the gravitational lens. The precise positions and brightness of these duplicate images are exquisitely sensitive to the granular details of the mass distribution along the line of sight. If there are unseen clumps of dark matter or satellite galaxies along the path, they will leave a tiny but measurable fingerprint on the relative positions of these quasar mirages. So far, the data suggests the Sombrero's hidden skeleton is not perfectly smooth. These gravitational lensing effects provide some of the most direct evidence that the dark matter halo possesses substructure, confirming it is a dynamic, complex entity. This natural lens is far more than a cosmic curiosity. It is a precision instrument. By studying these faint, warped lights in the void, we are essentially weighing the galaxy's invisible components and tracing their shape, using the universe's own physics to reveal secrets that no telescope could ever see directly. These gleaming star cities hold a chemical secret that defies their ancient age. The 19th strange objects are the Sombrero's metal-rich globular clusters. Most globular clusters are cosmic fossils composed of stars that are incredibly old and metal-poor, meaning they formed from the pristine hydrogen and helium of the early universe before many heavier elements existed. But a significant portion of the Sombrero's globulars are different, shining with the light of stars that are rich in elements like iron, silicon, and oxygen. This is a profound anomaly, like finding a tribe of ancient humans who somehow possess advanced modern technology. The high metal content tells us these clusters did not form in the isolated, quiet outskirts of the galaxy. Instead, they were born in the chaotic, dense heart of the young Sombrero, deep within its burgeoning bulge. This was a place where star formation was a frantic, continuous firestorm. Generations of massive stars lived and died in rapid succession, each one fusing lighter elements into heavier ones in their cores and then scattering them across space in violent supernova explosions. This process, called chemical enrichment, polluted the surrounding gas clouds with metals. The next generation of stars, including those that would bind together into these globular clusters, then formed from this enriched material. The puzzle is how such dense, massive clusters could form at all in that turbulent environment. The galactic center is a place of immense gravitational forces and fierce radiation, conditions that should tear apart nascent star clusters before they can properly coalesce. One theory suggests that the gas clouds that birthed them were incredibly massive and dense, collapsing under their own gravity so quickly and decisively that they forged these tight stellar cities before the surrounding chaos could disrupt them. Another equally compelling idea is that these are not true globular clusters at all in the traditional sense. Some of these metal-rich clusters may be the stripped nuclei of ancient dwarf galaxies that the Sombrero consumed. In a galactic merger, the outer stars of a small galaxy are easily torn away and scattered, but its central core, often a dense and metal-rich star cluster itself, is gravitationally tough enough to survive intact. The Sombrero's cannibalistic past, which we see evidence for in its tidal streams and lonely clusters, could have delivered these immigrant cores which we now mistake for native globular clusters. Their unusual chemistry is not from the Sombrero's enrichment, but is a relic of their own independent history in a different galaxy. These clusters are more than just strange, they are time capsules. Their starlight is a recorded history of the galaxy's most violent and creative era, a period of rapid construction and frantic element building. Each metal-rich cluster is a gleaming trophy from the Sombrero's explosive youth, a permanent reminder that this galaxy's serene beauty was forged in fire. This vibrant spiral is quietly running on empty. The 20th strange object is the Sombrero's unusually low gas content, a profound deficiency that challenges its very identity. For a galaxy of its immense size and majestic spiral structure, it possesses a surprisingly small reservoir of neutral hydrogen, the primary raw material for building new stars. This gas poverty is a silent crisis, one that radio telescopes have quantified with startling clarity. Observations from instruments like the Very Large Array, tuned to the faint radio whisper of hydrogen, reveal a galaxy that is far more gas-poor than any of its spiral cousins with comparable mass. The question is unavoidable. Where did all the gas go? One possibility is that the Sombrero was simply too efficient, that in its explosive youth it converted nearly all of its primordial hydrogen into stars in one intense, glorious burst of creation, leaving little fuel in reserve for the future. Another, more dynamic theory points directly to the supersonic galactic wind flowing from its core. That relentless outflow, powered by billions of years of supernova and stellar winds, may have acted as a cosmic blowtorch, systematically ejecting vast quantities of gas out of the galaxy and into the intergalactic void, permanently depleting its reserves. A third, more profound idea is that the Sombrero never accreted a large gas supply to begin with, perhaps due to its relatively isolated position in space. where few intergalactic gas clouds were available to fall in and replenish it. This gas shortage has direct and dramatic consequences for the galaxy's present and future. With so little neutral hydrogen left, the Sombrero's current star formation rate is severely limited. Its brilliant spiral arms, which in other galaxies would be bustling stellar nurseries, are now largely just grand architecture, a beautiful but aging structure with little ongoing construction. This forces us to see the Sombrero in a new light, not as a galaxy in its prime, but as one that has already passed its peak. It is a cosmic post-peak object, a brilliant spiral that has already done most of its life's work. Its future is one of gradual transformation, over billions of years as its existing stars age and its spiral structure slowly fades from a lack of new stars to define it. The Sombrero may inevitably transition into a lenticular galaxy, a featureless disk without arms, or even evolve further into an elliptical galaxy. This strange gas deficiency reveals that the Sombrero's vibrant beauty is, in many ways, a final masterpiece. It is a galaxy living on borrowed time, its glorious spiral form a temporary phase in a long, slow journey toward a very different and much quieter future. This hidden infrared glow forms ghostly loops on a cosmic scale. The 21st strange object is a set of mysterious infrared loops, vast structures that encircle the Sombrero Galaxy like faint, ethereal halos. These rings are completely invisible to our eyes and to optical telescopes, their light only emerging in the specific wavelengths of heat radiation detected by space observatories like Spitzer and Herschel. They are not part of the galaxy's beautiful disk or its warped dust lane, but exist far out in its halo, tracing patterns of warmth in the cold void. Their very existence is a riddle, a hidden dimension of galactic activity we never knew was there. What could possibly create such large, symmetrical structures of warm dust and gas so far from the galaxy's bustling center? One leading theory points to the collective fury of the galaxy's past. These loops could be the fossilized remnants of ancient supernova explosions that occurred in waves over millions of years. Each titanic blast would have sent a powerful shockwave racing outward, compressing and heating the thin gas of the galactic halo, and leaving behind these glowing rings as a permanent record of their violence. Another possibility is that they are bubbles blown by the fierce stellar winds from entire generations of massive stars. These winds, flowing out for eons, could have carved vast cavities in the halo gas, their inner surfaces heated and now glowing in the infrared. The symmetry of the loops is particularly telling. They are not random, chaotic splashes, but coherent, rounded structures. This suggests a coordinated, energetic event, something that released a tremendous amount of energy in a relatively short cosmic timescale. Could they be tidal features, the ripples from a past interaction with another galaxy, frozen in time as heated dust? Or is their origin even more deeply connected to the galaxy's invisible forces? The loops might be related to the Sombrero's magnetic field. Cosmic rays, those high-energy particles zipping through space, can be trapped by magnetic field lines, and as they spiral along these lines, they can heat up surrounding dust, causing it to glow in the infrared. The loops could be tracing the otherwise invisible architecture of the galaxy's magnetic halo, making the force fields visible for the first time. These strange, ghostly loops are a reminder that a galaxy's story is written in more than just starlight. They are a thermal echo of past violence, a hidden signature of energetic processes that continue to shape the galaxy from its outermost reaches inward, revealing an entire layer of activity that has been hiding in plain sight, waiting for the right eyes to see it. Even the galaxy's central monster may not be sitting where it belongs. The 22nd strange object is the tantalizing possibility that the Sombrero's supermassive black hole is slightly offset from the galaxy's true dynamical heart. This is a finding that would upend our basic understanding of galactic cores, suggesting the most powerful object in the galaxy is not at its center of mass but is instead wandering. Pinpointing the black hole's exact position is a feat of cosmic precision. Astronomers use astrometric measurements to compare the location of the black hole's observed radio emission, its fixed point in space, with the photometric center of the brilliant stellar bulge, the point of peak light density. They are essentially trying to align a silent, invisible marker with the galaxy's brightest beacon, a task complicated by the overwhelming glare of billions of stars. The challenges are immense, requiring the sharpest resolution of radio telescopes and the most careful analysis of optical data to see if these two centers are perfectly superimposed or if one is subtly shifted. A confirmed offset would be a seismic discovery. The most dramatic explanation is that the black hole received a powerful gravitational kick from a past event. If the proposed binary black holes at the core did indeed merge in the relatively recent past, the cataclysm would have been so violent and asymmetrical that it could have recoiled, sending the newly formed single black hole shooting out from the center at high speed, like a rocket firing in one direction. It would now be in the process of slowly drifting back to the center, oscillating through the core over millions of years. Alternatively, the gravitational influence of a second, still present black hole could be pulling the primary off-center, their complex dance creating a wobble in the system's core. The implications of a wandering black hole are profound. Its immense gravity would act as a destabilizing force, subtly distorting the orbits of millions of stars and vast clouds of gas in the central region. This would create a detectable asymmetry in the motions of stars near the core, a signature of a center of gravity that is not aligned with the center of light. The very stability of the galactic nucleus would be called into question. This potential offset, a deviation that might be smaller than the width of a human hair seen from a mile away, is a strange and subtle clue. It hints at a recent and violent event, a gravitational shockwave that is still echoing through the heart of the Sombrero, proving that even the most massive objects are not immune to the chaotic forces of the cosmos. Orbiting silently within the Sombrero's vast halo is a ghost of a galaxy, a candidate for the 23rd strange object, an ultra-diffuse galaxy. This is not a brilliant island of stars, but a cosmic wraith, a galaxy that is as large as the Milky Way in terms of physical size, but contains so few stars that its light is spread incredibly thin, making it nearly transparent. Spotting one of these UDGS is like trying to see a faint wisp of cloud on a brightly lit day, its ethereal form easily lost in the overwhelming glare of its brilliant host. These galaxies are strange in their own right, dominated not by stars but by dark matter. Their gravitational pull is strong enough to hold together a structure the size of our own galaxy, yet they have failed to form more than a tiny sprinkling of stars, leaving them as dark, shadowy versions of the vibrant spirals we know. Finding such an object orbiting the Sombrero would be a discovery of profound significance. It would represent a new class of satellite for this galaxy, a ghostly companion that has somehow avoided detection until now. Confirming its existence, however, is a monumental challenge. Astronomers must first distinguish its faint, uniform glow from the delicate tidal streams of stars that also wind through the halo, the remains of past galactic meals. They must also rule out the possibility that it is merely a distant background galaxy seen in projection against the Sombrero, a cosmic trick of perspective. This requires deep, multi-wavelength observations to study its color, its star population, and its motion. If it is truly bound to the Sombrero, its presence would reveal critical information about the galaxy's dark matter halo. The survival of such a large, fluffy galaxy so close to a massive neighbor suggests the halo is smooth and not filled with destructive clumps that would have torn it apart. Its very existence would be a vote of confidence for our models of dark matter, showing that it can form these vast yet faint structures. This ghostly candidate, barely a smudge of light against the cosmos, forces us to wonder how many other invisible giants are hiding in the halos of famous galaxies, a hidden population of cosmic phantoms waiting to be seen. Even a sleeping giant sometimes stirs. The 24th strange object is the Sombrero's anomalous radio jets, faint and ghostly outflows that whisper from the vicinity of its central black hole. Detected by the immense sensitivity of radio telescope arrays like the Very Large Array, these jets are a pale echo of the cosmic power we expect. In truly active galaxies, supermassive black holes fire off colossal, tightly focused beams of plasma that stretch for thousands of light years, brilliant lighthouses in the radio sky. The Sombrero's jets, by contrast, are weak and poorly collimated. They are diffuse, wavering tendrils of energy that lack the fierce discipline and raw power of their counterparts in other galaxies. Their very structure and radio spectrum act as a direct diagnostic of the black hole's current state, revealing an engine that is starved and sputtering. The spectrum of the radio emission suggests a low level of activity, a faint sizzle rather than a roaring blast furnace. This presents a fundamental puzzle. Why is a black hole of such immense mass, a billion suns strong, not producing the powerful jets its size suggests it should? The most straightforward answer is a simple lack of fuel. A black hole needs a steady, dense inflow of matter, a swirling accretion disk of superheated gas to power and focus its jets. The Sombrero's core appears to be in a state of famine, with very little material currently falling in. Without this constant fuel supply, the engine cannot roar to life, but the cause could be more complex than mere hunger. The strength and focus of these jets are also governed by the magnetic fields tangled in the black hole's vicinity. Perhaps the magnetic field geometry around the Sombrero's giant is inherently disordered or too weak to properly collimate the outflow, resulting in these faint, spreading whispers instead of a focused beam. There is another, more dynamic possibility. These jets might not be a permanent feature, but the dying embers of a past outburst. We could be witnessing the aftermath of a brief feast, a time when a gas cloud or a star wandered too close and was ripped apart, providing a short-lived burst of fuel that powered a temporary jet which is now fading away. This would make the jets intermittent, flickering on and off over millions of years based on the black hole's erratic diet. These faint radio signatures are a powerful reminder that a monster's quiet demeanor does not mean it is harmless, only that it is waiting. They show us a black hole in a deep state of dormancy, its immense potential for violence temporarily muted, its roar reduced to a faint and puzzling sigh in the radio static. The Sombrero Galaxy spins with a ferocious, silent speed. This rapid rotation is the 25th strange object, a kinematic whirlwind that defines its very shape and stability. While all spiral galaxies turn, the Sombrero's disk, particularly its inner regions, whirls at a velocity far greater than expected for its type. This is not a gentle cosmic waltz, but a frantic dance that helps maintain its iconic, razor-thin profile against the relentless pull of gravity. We measure this incredible motion through the subtle art of spectroscopy. By analyzing the light from countless stars and clouds of gas, astronomers can detect the tiny shifts in their color. Stars moving toward us glow slightly bluer, while those speeding away appear redder. This Doppler effect, the same principle that changes the pitch of a passing siren, allows us to map the rotation curve, a graph of how fast material orbits at different distances from the center. The results are unequivocal. The inner stars are racing around the core at breathtaking speeds. This frantic pace is a direct consequence of the galaxy's immense inner mass. That overmassive bulge we discussed earlier, a colossal concentration of stars, creates a gravitational well so deep that everything nearby must move incredibly fast to avoid falling in. The high rotation speed is the necessary counterbalance to this tremendous pull, a dynamic equilibrium that keeps the disk from collapsing inward upon itself. But how did this rapid spin originate? Was it an intrinsic property from the very beginning, a product of the specific conditions when the galaxy first coalesced from a primordial cloud of gas? Or has this spin been carefully maintained over billions of years through a specific evolutionary pathway, perhaps by avoiding major disruptive mergers that could have slowed it down? The implications of this rapid rotation are written in the galaxy's structure. It is this very speed that helps keep the dust lane so remarkably thin and well-defined. The centrifugal force from the spin flings material outward, counteracting gravity's tendency to let the disk thicken and puff up. It acts as a cosmic sculptor, ensuring the sombrero's brim remains sharp and elegant. Yet this defining feature is also a delicate balance. If the rotation were any slower, the disk would thicken and blur. If it were much faster, the galaxy might not have been able to hold onto its gas long enough to form its majestic structure. The sombrero's beautiful form is therefore a snapshot of a specific rotational velocity, a strange and precise spin rate that has crafted one of the universe's most perfect-looking galaxies. Scattered like faint red embers across the galaxy, the carbon stars of the sombrero form a peculiar pattern. These are the 26th strange objects, cool giants in the final stages of their lives, whose atmospheres have become strangely enriched with carbon. Their deep crimson color makes them stand out against the backdrop of hotter, bluer stars, but it is their unusual distribution and numbers that truly mark them as anomalies. Identifying them requires peering into their specific light signatures, their spectra revealing the distinct molecular bands of carbon compounds like cyanogen, a telltale sign of a stellar atmosphere where carbon atoms outnumber oxygen. This chemical imbalance is a hallmark of stellar evolution, a fleeting phase in the life of an intermediate mass star where deep-seated convection dredges up newly forged carbon from the core and spreads it across the star's outer layers. These carbon-rich giants are therefore cosmic clocks, tracing populations of stars that are not ancient, but not young either, shining a light on a specific era of the sombrero's history. Yet the map of these red beacons is not what astronomers expected. Compared to other galaxies of similar type and mass, the sombrero appears to have a distinct pattern, with carbon stars concentrated in certain regions of the halo and curiously absent in others. This is not a random scattering, but a structured fingerprint of the galaxy's past. The explanation likely lies in the sombrero's unique chemical evolution. The process of carbon star formation is exquisitely sensitive to a star's initial metallicity, the amount of heavy elements it was born with. If the sombrero's outer halo was built from the cannibalized remains of smaller, metal-poor galaxies, as the tidal streams suggest, then the stars formed from that debris would have a different propensity to become carbon stars compared to stars born from the galaxy's own, more metal-rich gas. The specific pattern we see could be a direct reflection of this violent assembly line history, a fossil record of which galactic building blocks were consumed and when. These strange red stars are more than just passive markers. They are active participants in the galaxy's chemical life cycle. In their final acts, carbon stars become cosmic dust factories. The carbon in their cool, extended atmospheres condenses into soot-like grains, which are then blown out into space by their powerful stellar winds. This carbon-rich dust is a fundamental ingredient for future planets and even life itself. The anomalous population in the sombrero suggests that the galaxy may have experienced a very specific timetable for seeding its interstellar medium with this critical element. Perhaps a burst of carbon star formation occurred following a major merger, flooding the galaxy with carbon dust at a precise moment, which then influenced the chemical makeup of the next generation of stars and planets. These fading red giants, therefore, hold the secrets to the galaxy's material wealth, their strange distribution a silent testament to the complex and violent processes that enrich the sombrero with the very elements that make worlds possible. The sombrero's spiral arms are wound incredibly tight, like a watch spring coiled around its brilliant core. This 27th strange object is a galactic structure so compressed it barely flares out from the central bulge, a design that defies the grand, sweeping arms of most spirals. According to spiral density wave theory, the graceful arms of a galaxy are not fixed structures, but moving traffic jams of stars and gas, created and sustained by gravitational perturbations. The speed and shape of these waves are dictated by the galaxy's overall mass distribution and rotation curve. In the Sombrero's case, the sheer gravitational dominance of its overmassive bulge creates a powerful central force field. This immense gravity acts like a cosmic anchor, pulling the spiral pattern inward and forcing the waves to travel on a much shorter, tighter orbit, resulting in these densely packed arms. This tight winding is a strong indicator of the galaxy's advanced age. A spiral pattern rotates at a different speed than the stars themselves, and over billions of years, the arms can wind up tighter and tighter. The Sombrero's compressed structure suggests its spiral has undergone many rotations, a slow and inevitable tightening that marks it as a cosmic senior citizen. The consequences of this design are profound for the galaxy's vitality. The tight arms leave little room for the vast, dense molecular clouds that typically trigger star formation. There is less space for gas to accumulate and collapse, which severely limits the birth of new, hot blue stars. This is why the Sombrero's spiral structure appears so subtle and monochromatic, lacking the bright blue stellar nurseries that line the arms of younger galaxies. Its majestic spiral is, in truth, a quiet and aging architecture, a beautiful fossil of a pattern that has slowly wound itself down over eons, its potential for new creation slowly strangled by its own elegant and relentless spin. These stellar fugitives are the high-velocity runaway stars, massive suns burning with a desperate intensity as they race toward the void. They are the 28th strange object, solitary beacons flung from the galaxy's crowded core, moving at speeds so great they are destined to escape the Sombrero's gravitational embrace entirely. Unlike the hypervelocity globular cluster we encountered earlier, which was a whole city of stars ejected together, these are individual outlaws, each on its own lonely trajectory into intergalactic space. Their spectra, the unique chemical fingerprints of their light, tell a clear and violent story. They are not the cool, ancient red stars typical of the galactic halo, but are instead hot, young, and massive O and B-type stars, the kind that should only exist within the vibrant spiral arms or dense star clusters. Finding them alone in the halo is like finding a deep-sea fish swimming in a desert, completely out of place. So how did they get there? The most likely explanation is a gravitational slingshot, a cosmic game of pinball in the galaxy's most extreme environments. In the dense core of a massive star cluster, a close encounter between a binary star system and a single, more massive star can result in a dramatic exchange. The single star can be captured by the binary, while the lowest mass star of the original trio is violently ejected at tremendous speed. Alternatively, the immense gravitational field of the central supermassive black hole binary, those twin monsters we suspect reside in the heart, can act as a powerful accelerator. A binary star system that ventures too close can be torn apart, with one star captured into a tight orbit and the other catapulted outward like a stone from a sling, reaching velocities that allow it to flee the galaxy forever. By tracing the paths of these runaway stars backward, astronomers can perform a form of cosmic forensics. The trajectory and speed of a stellar fugitive can often be traced right back to the bustling central regions or a specific, dense globular cluster, pinpointing the very location of the violent event that expelled it. These stars are therefore high-speed messengers from the galaxy's most chaotic districts. They carry with them the chemical composition of their birthplace, a record of the environment that forged them before they were so violently evicted. Each one is a testament to the incredible forces that can be unleashed in crowded stellar neighborhoods. forces powerful enough to give a single star the momentum to break free from its entire galaxy and sail alone into the eternal night. A faint, pervasive haze of X-ray energy permeates the Sombrero Galaxy, a collective whisper from a hidden population of stellar corpses. This unresolved X-ray background is the 29th strange object, a diffuse glow that our current telescopes cannot break down into its individual points of light. It is the combined signal of countless white dwarfs, neutron stars, and accreting binary systems, all shining with high-energy light but remaining just beyond our ability to distinguish one from another. Imagine trying to hear the murmur of a vast, unseen crowd from a great distance. You know people are there, but you cannot make out a single word. This is the challenge astronomers face with this faint, energetic fog. The Sombrero's unresolved glow has a specific spectral signature, a particular blend of energies that sets it apart from the X-ray backgrounds of other similar galaxies. This unique fingerprint suggests that the mix of stellar remnants in the Sombrero is somehow different. Perhaps it has an overabundance of a certain type of binary system where a compact object is slowly stripping material from a companion star. Or maybe its white dwarf population is unusually large, with many of them flaring up in nova explosions. The emission could even be partly generated by a vast, superheated interstellar medium, a thin plasma warmed by the collective fury of all those stellar explosions and winds over billions of years. The true composition of this energetic haze remains one of the galaxy's most persistent puzzles. Future X-ray observatories, like the proposed Lynx or Athena missions, are designed to have the resolution to finally dissect this glow. They will act like cosmic hearing aids, allowing us to pick out individual voices from the crowd. We will be able to count the numbers of neutron stars and white dwarfs, classify the types of binary systems, and finally understand the life cycle of stellar death in this unique galaxy. This unresolved background is more than just noise. It is a census of the unseen, a direct line to the galaxy's population of invisible compact objects. Solving its mystery will reveal a dark demographic, a hidden society of stellar remnants that have been silently shaping the Sombrero's energy budget and chemical evolution all along. Even the galaxy's isolation is an illusion, a trick of scale. The 30th strange object is the Sombrero's precise alignment with the supergalactic plane, a vast and invisible sheet that defines the local universe. This plane is the backbone of our cosmic neighborhood, a flattened structure where the majority of major galaxy groups and clusters are concentrated, a celestial freeway system for the cosmos. The Sombrero is not floating in a random void, but is positioned remarkably close to this immense highway, and this placement may hold the key to its entire history. This alignment suggests the galaxy has been shaped by its large-scale environment, a silent force that has guided its evolution over billions of years. The supergalactic plane is not just a map, it is a dynamic environment. Galaxies moving within this plane have a higher probability of gravitational encounters, of brushes and near misses with their neighbors. This could explain the Sombrero's violent past, evidenced by its tidal streams and cannibalized clusters. Perhaps its overmassive bulge was forged not in one single cataclysm, but through a series of minor mergers and interactions facilitated by its location in this cosmic traffic jam. Even the profound lack of satellite galaxies, the missing dwarf problem, could be a consequence of this environment. Over the eons, the gravitational pull of other large galaxies within the plane could have stripped away the Sombrero's entourage of small companions, or perhaps the conditions within the plane prevented them from forming in the first place. This placement may also govern the galaxy's very breath. The inflow of fresh, primordial gas from the intergalactic medium, the fuel for future stars, is not random. It flows along the filaments of the cosmic web, and the supergalactic plane is a major intersection of these filaments. The sombrero's position could mean it receives a specific, perhaps limited, supply of this gas, which might explain its current starved state and unusually low gas content. It could be situated in a cosmic desert within the plane, a region where the flow of intergalactic fuel has been shut off. Proving these connections is a monumental challenge. The effects are subtle, acting over timescales of billions of years, and the sombrero's relative isolation makes it difficult to find clear evidence of recent interactions. We are trying to read a history written in faint gravitational echoes. Yet, this strange alignment forces us to see the galaxy not as an island, but as a product of its address in the cosmos, its strangeness perhaps not born from within, but written into its location by the universe itself. A profound silence hangs where we expect to hear the final sighs of dying stars. The Sombrero Galaxy reveals its 31st strange object as a mysterious and significant lack of planetary nebulae, those beautiful, glowing shells of gas that sun-like stars puff away at the end of their lives. In other mature galaxies, surveys using specialized narrowband filters, which isolate the specific greenish glow of oxygen emitted by these nebulae, reveal them by the thousands like a field of cosmic fireflies. But in the Sombrero, the same meticulous searches with the Hubble Space Telescope and large ground-based observatories have found only a handful. The numbers are startlingly low, a deficit that cannot be easily explained. This is not merely a case of things being hard to see. It is a genuine absence, a missing population that should be there. The implications are deep, for planetary nebulae are more than just pretty lights, they are critical recyclers. They are the primary mechanism by which intermediate mass stars return their enriched material, carbon, nitrogen, and oxygen forged in their cores, back to the interstellar medium. This returned gas becomes the raw material for new stars, planets, and potentially life. If the Sombrero is not producing these nebulae, then a key part of its chemical cycle is broken or fundamentally different. What could cause such a shortage of stellar farewells? One possibility is that the galaxy's initial mass function was skewed. Perhaps in its formative years, the Sombrero simply forged far more high-mass stars, which explode as supernova, and far fewer of the intermediate mass stars that end their lives as planetary nebulae. Its stellar population would be top-heavy, a demographic bias written in fire billions of years ago. Another theory points to stellar evolution itself. The journey to becoming a planetary nebula is a delicate dance, requiring the star to lose its outer layers in a specific, gentle way. Perhaps the stars in the Sombrero, due to their unique chemical composition or the galaxy's intense radiation fields, lose their mass differently, shedding their envelopes too slowly or too quickly, preventing the formation of that iconic glowing shell. They might transition directly from red giants to white dwarfs without the brilliant planetary nebula phase, skipping their final performance entirely. We also cannot ignore the observational hurdles. The galaxy's immense distance makes individual planetary nebulae extremely faint points of light, and its intensely bright central bulge creates a glare that can easily wash out these delicate objects. Our searches might be like trying to spot a few faint candles in front of a massive, brilliant searchlight. Yet, even accounting for these challenges, the deficit remains. This strange absence forces us to reconsider the entire life cycle of stars in this unique galaxy. It hints at a different kind of stellar death, a quieter, more secretive passing that deprives the cosmos of both beauty and building blocks, leaving us to wonder what other stages of stellar life are unfolding here in ways we have never seen before. Deep within the galaxy's elegant spin, a silent river of gas flows against the current. The 30-second strange object is the Sombrero's counter-rotating gas disk, a portion of its interstellar medium that whirls in the exact opposite direction to the vast majority of its stars. This cosmic contradiction is not something we can see in a photograph. It is a secret written in the subtle shifts of light. Astronomers detect it through the precise art of spectroscopy. By carefully separating the light from the galaxy, They can isolate the signature of the stars from the signature of the glowing gas. The absorption lines from the stars show one clear velocity, a collective motion as they orbit the core. But the emission lines from the gas clouds tell a different story, a conflicting velocity pattern that reveals a component of the disk is spinning the wrong way. Such a profound mismatch does not occur naturally. It is the signature of a galactic theft. This backward spinning gas almost certainly came from outside the sombrero itself. The most likely culprit is a captured dwarf galaxy or a massive intergalactic gas cloud that was drawn into the sombrero's gravitational embrace. This external source had its own inherent spin, its own angular momentum, which happened to be oriented in the opposite direction to the sombrero's main disk. When it was finally consumed, its gas did not immediately align with the galaxy's rotation. Instead, it settled into the disk as a separate, counter-rotating stream, a stubborn river flowing upstream against a stellar tide. The presence of this contrary current has dramatic consequences for the galaxy's inner workings. Where the counter-rotating gas smashes head-on into the normally rotating gas, it creates immense shock fronts and regions of violent turbulence. This collision compresses the gas to extreme densities, acting as a powerful trigger for bursts of star formation. It is a chaotic and fertile frontier within the ordered disk, a place where the galaxy's past diet directly fuels its present creativity. This also creates incredibly complex orbital structures, as stars born from this counter-rotating gas inherit its strange motion, potentially creating stellar populations that move against the galactic grain. This strange, backward-flowing river is a dynamic fossil, a clear and present testament to the sombrero's active and ongoing history of accretion, proving that this cosmic masterpiece is still gathering material from its surroundings, one contradictory cloud at a time. Woven through the galaxy's visible splendor is an invisible architecture of immense power. The 33rd strange object is the sombrero's anomalous magnetic field, a force that permeates its entire structure with a surprising strength and coherency. We cannot see this field directly, but we can trace its ghostly lines by listening to the galaxy's radio whisper. When high-energy cosmic ray electrons spiral at nearly the speed of light around these magnetic field lines, they emit a specific type of polarized radio glow known as synchrotron radiation. By meticulously mapping the polarization of this light, astronomers can essentially draw the lines of the magnetic field, revealing its direction and intensity across vast stretches of space. The resulting map is not a chaotic tangle, but a surprisingly ordered and large-scale pattern, one that is unusually strong and well-organized for a galaxy of the sombrero's type. How does a galaxy build such a powerful and coherent magnetic scaffold? The engine is likely the galaxy's own rapid rotation. The sombrero's frantic spin, acting over billions of years, could have stretched and amplified a primordial seed field, winding it up into the strong, coherent structure we detect today, much like a spinning dynamo generates a magnetic field. Past merger activity may have also played a crucial role, with the violent turbulence of galactic collisions injecting immense energy and helping to order the field on a grand scale. This invisible magnetic web is not a passive observer, it is an active player in the galaxy's life. The field exerts pressure on the thin interstellar gas, influencing its flow and helping to support it against gravity's relentless pull. It can guide collapsing clouds, directly influencing where and how new stars are born, and it confines the paths of those high-energy cosmic rays, shaping the very radiation environment of the galaxy. The strangest clue, however, is the field's alignment. The magnetic field lines show a remarkable coherence with the galaxy's iconic dust lane and its tightly wound spiral arms. This is a profound connection. It suggests that magnetism and gravity are not independent forces, but are locked in a continuous dance. The gravitational forces that sculpt the spiral density waves and shape the dust lane are also orchestrating the magnetic field, and in turn, the magnetic field is providing a supporting framework that helps maintain the galaxy's beautiful, thin structure. This invisible force is a fundamental part of the sombrero's identity, a strange and powerful presence woven into the fabric of its being, silently guiding the flow of gas and the birth of stars from the shadows. Even the color of the sombrero's heart is a carefully crafted illusion. Its core burns with an unusually deep crimson hue, the 34th strange object, a shade that speaks of more than just ancient stars. While it is true that older stellar populations glow with a cooler, redder light, the sombrero's central bulge is redder than it should be, its light filtered through a unique and mysterious cosmic veil. This excessive reddening is not a trick of the light, but a direct result of the specific dust that permeates its innermost regions. The interstellar grains here are not like the fine, silty dust found in the galaxy's outer disk. After eons of enduring the harsh environment of the galactic core, they have been fundamentally altered. The intense radiation from the dense cluster of stars, the shock waves from frequent supernova, and the turbulent magnetic fields near the central black hole have all acted like a cosmic forge processing the dust. These extreme conditions may have caused smaller grains to evaporate entirely, leaving behind a population of larger, coarser particles. It is the difference between fine red chalk dust and coarse red sand, each scattering light in a distinctly different way. These larger grains are exceptionally efficient at scattering blue light away from our line of sight, allowing only the deep red wavelengths to pass through, thus painting the entire bulge with this anomalously rich crimson tint. This has profound implications for how we read the galaxy's history. The intense reddening can artificially mimic the signature of a stellar population that is even older and more quiescent than it truly is. We must ask, are we looking at a core composed solely of ancient suns, or is the light from a potentially more mixed population being filtered to appear uniformly ancient? This strange color could be masking a more complex story of star formation hidden behind a curtain of specialized dust. The mystery deepens when we consider the source of the dust itself. The central stars are known to be metal-rich, forged from gas that was heavily enriched by generations of previous stars. This high metallicity provides ample raw material for dust formation. Yet, the process that creates these specific, larger grains might be tied to the unique chemical enrichment cycles of the core, where elements were fused and scattered in ways not seen in the calmer galactic suburbs. The sombrero's red core is therefore a chromatic puzzle, a beautiful lie told by starlight. Its deep crimson glow is not just a sign of age, but a testament to a violent and complex past, a history written in the very size and composition of the dust grains that float in its central void. This ethereal, superheated shroud is the sombrero's ghostly halo of hot gas. Enveloping the entire galaxy is a vast, diffuse atmosphere of plasma burning at millions of degrees, a strange object detected only by its faint, lingering X-ray whisper. Space observatories like XMM Newton and Chandra have mapped this colossal, invisible structure, revealing a gaseous corona that stretches far beyond the galaxy's visible stars. This is not the cool, star-forming gas of the disk, but a thin, seething ocean of energy, a remnant of the galaxy's most violent and enduring processes. This halo is the ultimate reservoir, a collective memory of the energy pumped into space over billions of years. Its primary heat source is the relentless fury of supernova explosions and the powerful galactic wind flowing from the core. Every stellar cataclysm, every gale from a massive star, has contributed to warming this immense cloud, inflating it like a hot balloon around the entire galactic structure. The strange properties of this halo are its most telling features. Its sheer extent is vast, reaching distances that challenge our understanding of galactic atmospheres, and its temperature is remarkably uniform, suggesting a constant and efficient heating mechanism has been at work for eons. This hot gas is a fundamental component of the galaxy's baryon content, a direct measure of the normal matter that should be present but is often missing in our cosmic inventories. It represents a massive, previously hidden store of material, locked away in a form too energetic to form stars. This halo is the primary actor in the grand drama of galactic feedback. The immense pressure of this superheated gas acts as a barrier, a protective shield that regulates the galaxy's future. When cooler gas from the intergalactic medium tries to fall in and replenish the disk, it meets this wall of heat. The infalling gas can be slowed, heated, and even pushed away, preventing it from ever reaching the star-forming regions below. This process may be a key reason for the Sombrero's strangely low gas content and its quiet, red outer disk, the galaxy's own hot atmosphere silently starving it of the fuel it needs for new creation. Yet, this interaction is a two-way street. The galactic wind flowing up from the disk constantly injects new material and energy into the halo, while the sheer weight of the halo's gas can, in some regions, cool and condense, falling back onto the disk in a faint, hot rain. This ghostly million-degree shroud is therefore the galaxy's breathing apparatus, an energetic exhalation that governs its growth, its shape, and ultimately its long, slow fade into the cosmic night. The Sombrero's serene symmetry is a beautiful lie. Its star formation history is profoundly lopsided, a strange and patchy record written in the light of its ancient suns. The 36th strange object is this asymmetric star formation history, a clear sign that the galaxy did not evolve in a calm and uniform manner. While one half of the disk may be a quiet retirement home for old red stars, another region can harbor a surprisingly youthful population, a pocket of stellar adolescence that should not exist next to such ancient neighbors. We can read this uneven history by constructing color magnitude diagrams for millions of individual stars in the galaxy's outer regions. This technique is like taking a census of a city's population, but instead of age and occupation, we plot a star's color against its intrinsic brightness. The resulting pattern reveals everything. In a region that formed all its stars at once, billions of years ago, the diagram shows a clean, sharp turn-off point, with all the bright blue stars long since vanished, leaving only the older, redder stars. But in other parts of the Sombrero, the diagram tells a different story. The turn-off is fuzzy, and there are clear signs of stars that are significantly younger, indicating that star formation sputtered on in that specific locale long after it had died out everywhere else. This is not the signature of a galaxy that aged gracefully and uniformly. It is the record of a series of isolated firestorms, bursts of creation that ignited in one sector while the rest of the galaxy slumbered. What could trigger such localized violence? A minor merger with a tiny, gas-rich dwarf galaxy could have plowed into one specific section of the disk, its impact compressing the gas and igniting a furious but confined burst of new stars. Or two massive clouds of atomic hydrogen within the Sombrero's own disk could have collided, their chaotic crash creating a pocket of intense pressure. Even the galaxy's own tightly wound spiral arms, those density waves that move through the disk, could have triggered star formation as they passed. But if the wave was uneven or the gas distribution was patchy, the resulting starburst would be lopsided, leaving one spiral arm more active than the other. The very fact that these events were not symmetric is the key clue. It tells us that the triggers were external or random, not a global change affecting the entire galaxy at once. A galaxy-wide event, like a change in the dark matter halo, would have left a more uniform fingerprint. This patchwork history fundamentally reshapes our view of the Sombrero's evolution. It means the galaxy was not built in a single, monolithic collapse, but was assembled and rejuvenated in fits and starts, with its outer suburbs growing in an uncoordinated, almost haphazard fashion. This beautiful, swirling disk is not a single, coherent entity, but a mosaic of different histories, a quilt of stellar populations whose uneven seams tell a story of a turbulent and unpredictable past. The Sombrero Galaxy may be hiding entire cities of pure shadow. The 37th strange objects are the mysterious dark cluster candidates, hypothetical gatherings of dark matter so dense they act like gravitational glue, yet containing so few stars they are nearly invisible to our telescopes. These would not be star clusters in any traditional sense, but rather islands of near-perfect darkness, bound together by the universe's most elusive substance. We cannot see them directly, so we must search for the subtle ways they bend the fabric of reality around them. One method is to watch for the telltale flicker of a background star. If a dark cluster passes in front of a distant sun, its gravity will act as a miniature lens, briefly magnifying the star's light in a specific, fleeting pattern known as a microlensing event. Another approach is to study the precise motions of the stars and gas clouds we can see. If a stream of stars is flowing smoothly through the halo and suddenly shows a kink or a warp, it could be the signature of an unseen mass, a dark cluster's gravity subtly tugging at the visible universe as it passes by. The very idea of such objects is driven by our most fundamental theories of cosmic structure. The dark matter halo around a galaxy like the Sombrero is not believed to be perfectly smooth. Instead, it should be filled with a swarm of smaller substructures, clumps of dark matter that condensed in the early universe. Some of these clumps may have been the seeds of dwarf galaxies that failed to shine, their gas never cooling enough to collapse into stars. Others could be the stripped cores of ancient dwarf galaxies that were devoured by the Sombrero long ago, their stars torn away and scattered, but their dense, dark matter hearts remaining intact, drifting through the halo like ghostly sharks. Confirming their existence is one of modern astronomy's greatest challenges. A detected signal could be caused by a more ordinary object, like a faint globular cluster or a rogue planet. Distinguishing the unique gravitational signature of a pure dark matter clump requires exquisitely precise and repeated observations, a painstaking process of elimination. Yet the reward for such a discovery would be revolutionary. Finding a dark cluster would provide the first direct proof that dark matter can form these compact, stable structures independently of stars. It would open a new window into the properties of dark matter itself, potentially revealing whether its particles can interact with each other in ways beyond gravity. These phantom islands are the ultimate cosmic ghosts, and their potential presence within the Sombrero reminds us that the most common substance in the universe might also be the most secretive, hiding in plain sight within the galaxy's beautiful, luminous form. The warmth of the Sombrero Galaxy holds a hidden signature we cannot feel. Its far-infrared glow, detected by telescopes like Herschel, reveals a spectrum of heat that stubbornly refuses to follow the rules. This is the 38th strange object, an anomalous emission that complicates our understanding of the galaxy's cold, dark places. When astronomers measure the spectral energy distribution, a graph of how much light the galaxy emits at each infrared wavelength, they find an unexpected bump, an excess of energy at specific far-infrared and submillimeter wavelengths. This is not the smooth curve you would expect from standard starlight simply warming ordinary cosmic dust. It is a spectral hiccup, a clear sign that something unusual is happening in the galaxy's chilly outskirts. One explanation points to the existence of a vast reservoir of incredibly cold dust, far colder than we typically find, with temperatures only a few degrees above absolute zero. This dust would be so frigid that it emits most of its energy at these very long wavelengths, creating the observed excess. But how could such cold dust exist in a galaxy with a brilliant central bulge? It might be shielded in the outermost, quietest regions, or perhaps it is made of different materials with unusual grain properties that allow it to cool more efficiently. An even more exotic idea involves spinning dust nanoparticles. These are tiny, electrically charged molecules or very small grains that rotate at phenomenal speeds. As they spin, they emit radiation at specific microwave and far-infrared frequencies. a process that could be responsible for the peculiar bump in the Sombrero's energy signature. This discovery forces a recalculation of the galaxy's entire dust budget. If this cold dust component is real and widespread, it means we have been underestimating the total mass of solid material floating between the stars. This hidden dust could represent a significant fraction of the galaxy's heavy elements, locked away in a form we have only just begun to detect. The anomaly might be intrinsically linked to the Sombrero's other great mysteries. Its low gas content and lopsided star formation history have left vast regions quiet and undisturbed for eons, the perfect environment for dust to settle and grow cold without being heated or destroyed by newborn stars. This strange far-infrared whisper is therefore a cold echo of the galaxy's quiet present, a direct consequence of its aging and starved state. It is a hidden aspect of the Sombrero's energy budget, a thermal secret proving that even in its apparent silence, this galaxy is communicating in a language of cold light we are still learning to understand. Deep within the galaxy's violent heart, the central black hole is encircled by a small, misaligned engine. This 39th strange object is the tilted nuclear disk, a compact ring of gas and dust orbiting the supermassive black hole at a sharp angle to the main galactic disk. It is as if the galaxy's core has its own private, spinning carousel that refuses to follow the direction of the larger cosmic dance. We cannot see this disk with our eyes, but its presence is betrayed by the specific molecular emission lines in its light, the unique fingerprints of carbon monoxide and other gases spinning at ferocious speeds in a plane all their own. This profound misalignment is a clear sign that this gas did not come from the Sombrero's main disk. Instead, it is likely the remains of a captured object, a small galaxy or a massive gas cloud that was drawn into the core from an unusual trajectory. This external source possessed its own inherent spin, its own angular momentum, which was oriented at a steep angle relative to the galaxy's primary rotation. When it was consumed, its gas settled into this stubbornly tilted orbit around the black hole, refusing to align with the established order. This strange configuration is not stable, it is a source of constant, violent drama. The tilted disk is subject to a phenomenon called precession, where its entire structure slowly wobbles like a spinning top beginning to fall. This wobble creates immense gravitational stresses. Where the tilted disk intersects with the galaxy's larger equatorial plane of gas, it creates powerful shock fronts. These collisions are like cosmic traffic accidents on a monumental scale, robbing the gas of its orbital energy and causing it to fall precipitously inward toward the waiting black hole. This misalignment could be the very mechanism that occasionally wakes the dormant giant from its slumber, funneling fresh fuel directly into its maw in sudden, chaotic bursts rather than a steady stream. Could the presence of a second supermassive black hole, the suspected companion in the galaxy's core, be influencing this chaotic dance? The gravitational pull from a binary partner would constantly tug on the tilted disk, warping it further and enhancing the precession. This could create an even more unstable and efficient feeding mechanism, a gravitational stir that ensures no gas remains in a stable orbit for long. This small, tilted disk is therefore more than just a curiosity. It is a key regulator of the central monster's appetite. Its strange angle is a direct line to the black hole's sporadic and violent feeding schedule, a misaligned engine that drives the very heartbeat of the galaxy. One of the few companions to this cosmic giant is itself a world of profound strangeness. The 40th mysterious object is the satellite galaxy NGC 4487b, a faint, ghostly smudge of light orbiting the Sombrero at a perilous distance. This is not a miniature spiral or a neat elliptical, but an irregular, misshapen blob, a celestial snowball slowly melting in the heat of its host's immense gravity. Its surface brightness is so low it barely registers against the blackness of space, a testament to its diffuse and fragile nature. This satellite's very survival is a puzzle. Billions of years ago, the Sombrero likely devoured dozens of similar dwarf galaxies, yet this one remains, albeit in a state of slow destruction. Its orbit is the key to its prolonged existence. NGC 4487b follows a wide, looping path that keeps it far from the galaxy's dense core for long periods, allowing it to avoid the immediate, violent disruption that would occur on a tighter orbit. But this relative safety is an illusion. With every close pass it makes, the Sombrero's tidal forces pull at it with invisible hands. These forces are a relentless gravitational tug of war, stretching the small galaxy and pulling its stars and gas away into long, faint streamers. We are likely witnessing the opening acts of a multi-billion-year process of dissolution, where the satellite is being slowly unraveled, its material donated to the vast halo of its devourer. This distorted companion is a living laboratory for galactic cannibalism. Its irregular morphology is not its original shape, but a direct result of this ongoing gravitational harassment. The Sombrero is quite literally twisting this galaxy out of shape, and by studying the exact nature of the distortion, astronomers can measure the strength and structure of the Sombrero's gravitational field in 3 dimensions. The properties of this strange satellite tell a sobering story about the population of dwarf galaxies in the halo. Its faintness and irregularity suggest that the survivors of the Sombrero's feasts are not the bright, robust dwarfs, but the faintest and most diffuse, the ones that are hardest to see and perhaps harder to completely destroy. It forces us to ask if the missing satellite problem is really a problem of visibility, and that the Sombrero's halo is in fact filled with these nearly transparent ghosts, each one being slowly digested over cosmic time. There is a compelling possibility that NGC 4487b is the source of some of the faint tidal streams we have already detected winding through the Sombrero's halo. The stars being stripped from it today are adding to those ancient rivers of light, contributing new material to the galaxy's ever-growing collection of celestial fossils. This faint, distorted companion is not just an independent object, it is becoming part of the Sombrero itself, its substance and its story slowly merging with the greater whole, a silent partner in the endless cosmic dance of creation and destruction. A strange, invisible sea of high-energy particles fills the Sombrero Galaxy, a population of cosmic rays that does not behave like our own. These are not rays of light, but atomic nuclei stripped of their electrons and accelerated to nearly the speed of light, a relentless, invisible rain zipping through the void. We cannot see them directly, but we can detect their ghostly footprints in the radio and gamma ray light they leave behind. As these frantic particles spiral around the galaxy's magnetic field lines, they emit a faint, characteristic radio glow known as synchrotron radiation. Meanwhile, when they collide with the nuclei of atoms in the sparse interstellar gas, they can produce the very gamma-ray whisper we detected earlier. The strange part is the intensity and spectrum of these emissions. The cosmic rays in the Sombrero appear to be more numerous or perhaps more energetic in certain ways than we would predict for such a seemingly quiet galaxy. This suggests a fundamental difference in the population of these invisible particles compared to what we find in our own Milky Way. What cosmic engine is so efficiently churning out these high-energy projectiles? The primary suspect is the collective fury of supernova explosions. Each stellar cataclysm acts as a natural particle accelerator, its expanding shock wave acting like a cosmic surfboard, pushing protons and atomic nuclei to incredible speeds. Yet here lies the puzzle. The Sombrero does not have a high current rate of star formation, which means its supernova rate should be relatively low. So why is the cosmic ray signal so pronounced? The answer may lie in the galaxy's unique ability to trap these particles. The Sombrero's strong and coherent magnetic field, that invisible scaffold we discussed, could act as a nearly perfect cosmic bottle. Once the cosmic rays are accelerated by a supernova, the magnetic fields prevent them from quickly escaping into intergalactic space. They become trapped, bouncing back and forth within the galactic disk for millions of years, their numbers building up into a more intense and potent sea than in galaxies with leakier magnetic fields. This creates a strange paradox. The Sombrero's quiet nature and low star formation might actually be the reason its cosmic ray population is so anomalous, its magnetic fields acting as a perfect prison for these energetic particles. The greatest mystery, however, is the absence of a central powerhouse. Most galaxies with a strong cosmic ray population have an active supermassive black hole at their core, a brilliant quasar pumping out particles. The Sombrero's black hole is dormant, a sleeping giant that provides no such central engine. This means the cosmic rays are being produced and distributed entirely by decentralized sources, primarily supernova scattered throughout the disk and bulge. It reveals that a galaxy does not need a monster at its heart to fill itself with high-energy particles, that the steady, cumulative simmer of stellar deaths is more than enough to create this invisible, energetic ocean. These cosmic rays are a hidden force shaping the galaxy's ecosystem. Their immense energy helps to heat the interstellar gas, making it more difficult for clouds to collapse and form new stars. They influence the chemistry of distant gas clouds and contribute to the pressure that supports the galaxy's structure against gravity's pull. The Sombrero's strange sea of particles is a testament to the enduring power of stellar life cycles, an invisible energy budget that governs the galaxy from the shadows, proving that even in silence, a universe of violent motion thrives unseen. This unresolved stellar background is a strange, collective glow from billions of unseen suns. It is a smooth, seamless veil of light, a shimmering fog composed of countless individual stars that our current telescopes cannot separate. Each point of light we see in the Sombrero is actually a blend of thousands, even millions of distant suns, their identities lost in the crowd. This collective glow is the 42nd strange object, a luminous secret hiding in plain sight. To decipher it, astronomers use clever techniques that listen to the hum of the crowd rather than individual voices. One method studies surface brightness fluctuations. Imagine looking at a vast beach from a great distance. You cannot see individual grains of sand, but you can perceive the texture of the beach. A smooth, fine sand will have a different texture than a beach of coarse pebbles. In the same way, by analyzing the subtle pixel-to-pixel variations in the galaxy's smooth light, scientists can statistically determine the average size and brightness of the dominant stars creating that glow. Another technique, integrated light spectroscopy, acts like a cosmic blender. It takes the combined light from millions of stars, mixes it into a single spectrum, and analyzes that blended light for the chemical signatures of the entire population. It reveals the average age and metallicity, the overall richness in heavy elements of the galaxy's stellar citizens. The findings from this collective light are deeply puzzling. The unresolved background suggests a potential anomaly in the galaxy's initial mass function, the foundational recipe for star birth. This is the cosmic rulebook that dictates how many low-mass stars are formed for every high-mass star. In most galaxies, this ratio is remarkably consistent, but the Sombrero's background light hints that its rulebook might have been different. The data suggests a possible overabundance of low-mass, faint red dwarf stars, or perhaps a deficit of them compared to what our standard models predict. This would mean that in its formative years, the Sombrero forged stars with a different preference, favoring either an army of small, long-lived suns or a brighter, more extravagant population of massive giants. The implications of this are staggering. If the galaxy is truly swarming with more red dwarfs than we think, its total stellar mass would be far greater than current estimates, which would, in turn, force us to recalculate the amount of dark matter needed to hold it all together. It would mean the Sombrero is an even more massive and dominant entity than we ever realized. The promise of resolution lies with the next generation of extremely large telescopes, like the giant Magellan telescope and the 30-meter telescope. Their colossal mirrors will act like ultimate cosmic microscopes. They will pierce the smooth veil of light and resolve this background into a glittering tapestry of individual points. We will see the red dwarfs, the sun-like stars, and the aging giants separately for the first time. This will transform the smooth hum into a distinct chorus, allowing us to take a direct census of the galaxy's stellar population and finally read the true story written in the light of its billions of hidden suns. A sudden crackle of cosmic static lasted less than a blink of an eye. This is the 43rd strange object, a candidate fast radio burst from the direction of the Sombrero Galaxy. It was not a sustained signal, but a single millisecond-long blast of radio waves that appeared, flashed with immense power, and then vanished back into the silence from which it came. Fast radio bursts are one of the most profound puzzles in modern astronomy. They are incredibly energetic events, capable of releasing more energy in that thousandth of a second than our sun puts out in 3 whole days, yet their sources remain stubbornly elusive. To have such a signal point toward the Sombrero would be a discovery of monumental importance. It would anchor one of the universe's most fleeting and powerful phenomena to a specific, well-studied galaxy, giving us a precious laboratory to investigate its origin. The most compelling theory for some fast radio bursts involves a specific type of stellar corpse known as a magnetar. These are neutron stars with magnetic fields so powerful they could strip the information from a credit card from halfway across the solar system. A starquake on the surface of such a monster, a sudden cracking of its rigid crust, could unleash a titanic blast of radio energy, a scream of magnetic fury that travels across millions of light years. Associating a fast radio burst with the Sombrero would strongly suggest a magnetar is lurking within its vast stellar population, a hidden powerhouse of unimaginable magnetic strength. Yet the challenge of pinpointing such a brief signal is immense. The vastness of space plays tricks on our observations. The radio burst candidate was detected in a patch of sky that contains the Sombrero, but our telescopes cannot yet localize its origin with the precision needed to be absolutely certain it came from within the galaxy itself. It could be a source far in the distant background, a galaxy billions of light years behind the Sombrero, whose signal just happened to travel along the same line of sight. There is also the persistent, nagging possibility that it was not cosmic at all, but a terrestrial artifact, a burst of human-made radio interference that mimicked the signature of a true fast radio burst. Since that initial, tantalizing detection, astronomers have pointed the world's most powerful radio dishes back toward the Sombrero again and again, listening intently for a repeat performance. So far, the silence has been unbroken. The galaxy has not produced a second burst. This is both frustrating and revealing. Many fast radio bursts are one-off events, while others are known to repeat sporadically. The Sombrero's silence suggests that if the event was real, it may have been a singular cataclysm, a one-time cosmic event that we were fortunate enough to catch. This single, unconfirmed crackle of radio noise remains a ghost in the machine, a modern mystery that hangs over the galaxy. It is a reminder that some of the universe's most violent secrets announce themselves only once, in a whisper of static that is as brief as it is powerful, leaving us to wonder what other transient wonders we have missed in the eternal dark. This invisible imbalance is a gravitational ghost haunting the entire galaxy. We must return to the Sombrero's lopsided dark matter halo, the 44th strange object, because new evidence reveals just how profoundly askew this unseen scaffold truly is. The clues are not written in light but in motion. At the galaxy's outermost fringes, far beyond the bright disk, astronomers track the movements of rare tracer objects, lonely globular clusters, and faint planetary nebulae. Their velocities tell a chaotic story. Instead of following the smooth, predictable orbits dictated by a spherical halo, these tracers move with strange, inconsistent speeds, their paths suggesting they are being pulled by a gravitational field that is heavier on one side than the other. This is like trying to run on a track that is mysteriously tilted, forcing you to constantly fight against a strange, invisible slope. Another line of evidence comes from the subtle art of weak gravitational lensing. By analyzing how the sombrero's mass distorts the shapes of millions of background galaxies, scientists can map its total gravitational field. The resulting map is not a perfect circle. It shows a distinct asymmetry, a gravitational pull that is stronger and extends farther in one particular direction, as if the galaxy's hidden mass has been stretched and pulled out of shape. This lopsidedness is a direct challenge to our most fundamental computer simulations of the universe. These models consistently show that dark matter halos should relax into stable, nearly spherical shapes over billions of years. A halo that remains lopsided is a system that is not in equilibrium. It is a galaxy that has been violently shaken and has not yet settled down. The most compelling cause is a recent major merger. Perhaps within the last few billion years, a substantial galaxy collided with and was absorbed by the sombrero. The gravitational turmoil of that collision would have sloshed the dark matter like water in a moving bowl, leaving it permanently slanted. Alternatively, the galaxy could be in the process of actively accreting a massive stream of dark matter from the cosmic web right now, a continuous inflow from one side that is constantly pulling the halo out of balance. Measuring this imbalance with precision is one of astronomy's greatest challenges. The tracer objects at these vast distances are incredibly faint and few in number, like trying to map the shape of a mountain by studying only 3 trees on its slopes. Each data point is precious, and each one seems to tell the same strange story of a gravitational core that is fundamentally off-center. This invisible lopsidedness has direct and dramatic consequences for the galaxy's beautiful visible form. An asymmetric halo exerts an uneven gravitational pull on the stellar disk. Over immense timescales, this constant, one-sided tug could warp the disk, potentially thickening it or causing it to wobble in a slow, cosmic procession. It threatens the long-term stability of the sombrero's iconic thin profile, suggesting that the perfect symmetry we see today might be a temporary and fragile state. The galaxy's serene appearance masks a deep gravitational imbalance, a hidden lean that could, over eons, fundamentally reshape this cosmic masterpiece. Scattered like brilliant sapphires among ancient suns, the Sombrero Galaxy harbors stars that refuse to grow old gracefully. These are the blue stragglers, the 45th strange object stellar anomalies that burn with a youthful, hot blue light despite being surrounded by much older, cooler stars. They are cosmic imposters, appearing billions of years younger than the ancient stellar populations they call home, a direct defiance of our understanding of how stars evolve and die. In a typical old star cluster, all the stars formed at roughly the same time from the same cloud of gas. The most massive stars live fast and die young, leaving behind only the slower-burning, lower-mass stars that glow with a cool red or yellow light. Blue stragglers shatter this simple timeline, shining with an intensity that should have been extinguished eons ago. So how do these stars cheat death? They are not truly young, they are rejuvenated. The leading theory is that they are the products of stellar violence or intimacy. In the crowded core of a globular cluster, 2 lower mass stars can collide and merge, their material combining to form a single, more massive and hotter star. Alternatively, in a binary star system, one star can siphon gas from its companion, feeding on its outer layers until it gains enough mass to reignite its nuclear furnace and blaze with a new blue-hot intensity. These stars are literally born again from cosmic cannibalism or catastrophic mergers. What makes the Sombrero truly strange is the unusual frequency and distribution of these stellar phoenixes. Across its vast collection of globular clusters and within its general field of stars, the number of blue stragglers is significantly different from what we see in other galaxies like our own Milky Way. Some of the Sombrero's massive, dense clusters are absolutely teeming with them, while others have surprisingly few. This patchy distribution is a direct tracer of each cluster's unique dynamical history. A cluster packed with blue stragglers is a cluster that has lived a violent life. It tells us that stellar encounters in that cluster's core are frequent and dramatic, that stars have been dancing a perilous gravitational waltz for billions of years, constantly brushing past one another, colliding, and merging in a frenzy of stellar rebirth. The clusters with fewer blue stragglers are likely calmer, more sedate environments where stars have aged in peaceful isolation. This pattern across the entire galaxy reveals the Sombrero's past in a new light. The high overall production of these stars suggests an environment that is exceptionally efficient at stirring up its stellar populations. The galaxy's immense central bulge and its history of mergers and acquisitions have created a system of globular clusters that are often denser and more dynamically active than average. The gravitational shocks from past galactic interactions may have compressed these clusters further, driving their stars closer together and increasing the rate of collisions and binary mergers. The blue stragglers are therefore celestial forensic evidence. Each one is a glowing monument to a past close encounter, a stellar crime scene where two stars became one. By mapping their locations, we are not just charting strange stars, we are reading a history of gravitational interactions that spans the entire lifetime of the galaxy. These defiant blue jewels prove that even in the quietest corners of the cosmos, the lives of stars are anything but peaceful, marked by sudden acts of violence and rebirth that keep the galactic population forever young at heart. Wrapped around the galaxy like the ghostly rings of a celestial tree trunk, these are the faint outer shells. They are the 46th strange object, immense but nearly invisible ripples of stars expanding through the Sombrero's outer halo. Spotting them is a monumental challenge, like trying to see the faintest etchings on a stone held up to the sun. Only through the deepest possible imaging, using the world's most powerful telescopes to collect light for hours on end, can these delicate structures be teased out from the overwhelming blackness of space. They are not random splashes of light, but precise, concentric arcs, the classic and undeniable signature of a past galactic meal. These shells are formed by the elegant yet violent physics of a dwarf galaxy being torn apart. As the smaller galaxy was captured by the Sombrero's immense gravity, it was stretched into a long stream of stars, just like the tidal streams we've seen. But in this specific type of merger, the stars do not simply form a single river. Instead, as they follow their new orbits within the Sombrero's gravitational bowl, they begin to oscillate, moving in and out like a cosmic pendulum. Stars that were stripped at the same moment in the disruption process share similar energies and oscillate in sync. Over time, they pile up at the turning points of their orbits, the peaks of their gravitational swing, creating these dense, shell-like caustics. It is a wave of stars frozen at the apex of its motion. The number and spacing of these shells are a detailed record of the ancient collision. A few well-separated shells suggest a merger that happened long ago, giving the stars ample time to complete many orbits and spread out. A larger number of tightly packed shells points to a more recent event where the stellar oscillations are still closely grouped. By counting these ripples and measuring their vast diameters, which can span hundreds of thousands of light years, astronomers can effectively rewind the clock, determining not just when the dwarf galaxy was consumed, but also the original trajectory of its fatal approach and even an estimate of its mass. The profound faintness of the Sombrero's shells is itself a critical clue. It tells us that the devoured galaxy was no giant, but a truly small and faint dwarf, one that contributed relatively few stars to the halo. Its light was simply overwhelmed by the Sombrero's native brilliance. This ghostly evidence completes a picture of the galaxy's growth. The Sombrero was not built by a single, cataclysmic merger with an equal, but through a steady diet of minor acquisitions, a slow and patient consumption of the cosmic small fry that once shared its space. These shells are the final, fading echoes of that process, a ripple in the stellar pond that has taken billions of years to reach the edges, a silent testimony to a long-concluded feast. A natural laser of pure water vapor pulses from the Sombrero's dark heart. This is the 47th strange object, an anomalous water maser, a beacon of microwave light that should not exist in a galaxy of such quiet maturity. A maser acts like a cosmic laser, but instead of visible light, it amplifies microwave radiation. It occurs when water molecules trapped in the dense, hot gas around newborn stars or swirling near a black hole are energized by a nearby energy source, causing them to emit radiation in a perfectly synchronized, coherent beam. This creates an intensely bright spot at a very specific frequency, a sharp spike of energy that stands out against the background radio noise of the galaxy. The very existence of this maser in the Sombrero is a profound contradiction. This galaxy has a low star formation rate and a dormant central black hole, two conditions that should not provide the intense energy needed to power such a brilliant and rare microwave beacon. Its presence is a direct challenge to our assessment of the galaxy's current activity, forcing us to admit that we have underestimated the hidden violence still churning within its dust lanes. The location of this maser holds the key to its origin. Is it nestled within a dense, hidden stellar nursery, a pocket of frantic star birth that our optical telescopes have missed? In this scenario, the intense ultraviolet light from a cluster of newborn, massive stars pumps energy into the surrounding water molecules, exciting them to emit their coherent microwave scream. This would mean that despite the galaxy's overall quiet state, there are still secret, violent firestorms of creation igniting within its dark clouds. The other, more exotic possibility is that the maser originates from the accretion disk of material swirling perilously close to the supermassive black hole itself. The immense gravitational energy and friction in this region could heat the gas and water vapor to the point of maser emission. This would be a clear sign that the central monster is not completely asleep, but is still nibbling, its faint appetite just enough to power this strange, localized phenomenon. The maser's own light tells a detailed story of its motion. Its emission is not a single, pure tone, but is broadened and shifted across a range of frequencies. This velocity structure is a direct map of the gas's high-speed rotation, whether around a newborn star or the black hole. By analyzing the precise Doppler shifts of this microwave light, astronomers can measure the rotation speed of the gas with incredible accuracy, effectively weighing the central object it orbits. This makes the water maser one of the most powerful tools in all of astronomy for cosmic cartography. A major, ongoing effort aims to use this maser to pin down the Sombrero's distance with unprecedented precision. By observing the maser spots over time with radio interferometers spanning the globe, scientists hope to track their tiny apparent motions against the more distant background of the universe. This technique, called astrometry, could measure the galaxy's distance directly, bypassing the entire uncertain cosmic distance ladder and its rebellious Cepheid variables. A precise distance would finally tell us the true physical scale of every other mystery we have encountered, from the size of its overmassive bulge to the mass of its dark matter halo. This single, strange spike of microwave energy is therefore more than a cosmic curiosity. It is a potential key to unlocking the galaxy's fundamental dimensions. It is a coherent whisper of water in the void, a testament to hidden forces that refuse to be silent, offering a chance to measure the cosmos with a ruler of pure light. Even the galaxy's slow drift across the sky holds a hidden irregularity. The 48th strange object is the Sombrero's anomalous proper motion, a minuscule but vital measurement of its actual path through the cosmos. This is not the galaxy's rotation, but its sideways glide as a whole against the backdrop of the universe, a movement so slow it would be invisible to a human watching for 1,000 lifetimes. To detect this tiny shift, astronomers turn to the most precise tools in existence. They use very long baseline interferometry, linking radio telescopes across the globe to create an instrument the size of the Earth itself, achieving a resolution so sharp it could theoretically read a newspaper on the Moon. They also track the galaxy's position against the fixed, unmoving points of distant quasars, the brilliant cores of galaxies billions of light-years away, which serve as perfect cosmic mileposts. The measurements demand phenomenal precision, a sensitivity to movements smaller than a single pixel in a telescope's camera over a period of many years. The data reveals a subtle discrepancy. The Sombrero is not moving exactly where our best models of local galactic flows predict it should be. Its path seems to have a slight, unexpected kink. This tiny anomaly could be a sign of unseen mass tugging at the galaxy, a vast, invisible clump of dark matter in the intergalactic void, or the gravitational pull of a completely unseen galaxy lurking in the dark could be gently steering the Sombrero off its expected course. Alternatively, the error might lie in our maps of the local universe. Our understanding of the grand currents that move galaxies within the Virgo supercluster, the immense metropolitan area of space we inhabit, could be incomplete. The Sombrero's strange path might be revealing hidden contours in this cosmic landscape, showing us that the gravitational rivers we thought we understood have unexpected bends and eddies. The implications of this tiny drift are profound, for they speak to the galaxy's ultimate destiny. Is the Sombrero on a long, slow orbit that will eventually bring it closer to other giant galaxies, leading to a cataclysmic merger billions of years from now? Or is its path carrying it away, sentencing it to a future of ever deeper isolation in the cosmic void? This minuscule, anomalous motion is a single line in a galactic biography, a subtle clue to the final chapter of this cosmic masterpiece, written in the imperceptible shift of its light over eons.